Okay, Unit 18. The first thing we need to do is review Pythagorean's theorem. So remember, Pythagorean's theorem is used when you have right triangles. That means you have a 90-degree angle. It also is used when you have two sides known. So, Pythagorean's theorem, a squared plus b squared equals c squared. Let's review the parts of a triangle. So mathematically, we call the two sides the legs. Okay, the legs are the sides that make up the right angle. And the third side is the longest side. We call that the hypotenuse. Now, to get a little bit more into plumbing terms, the vertical side we often call the rise, and the horizontal side is often called the run. Now, the third side, the longest side, is referred to as the diagonal. Okay, one other word that's used interchangeably for the legs is the offset. And the offset is just referring to the sides of the triangle. So these are the vocab words that you're going to need to be familiar with for Pythagorean's theorem. Okay, so let's try a Pythagorean's theorem problem here. Let's say we have a right triangle, and let's say we know that this side is 3 inches, this side is 4 inches, and this side is I don't know. Now, Pythagorean's theorem, again, is a squared plus b squared equals c squared. And a and b are referring to the sides or the legs of the triangle. So these would be my a and my b. So to plug into Pythagorean's theorem, I would say 3 squared plus 4 squared equals c squared. And instead of c, I'm going to use x just because that's what we put on the triangle for the diagonal. Now, time to math it out. 3 squared means 3 times 3, so 9. Plus 4 squared, 4 times 4 is 16, equals x squared. And then 9 plus 16 gives us 25, equals x squared. Now, our goal is to have x be alone, and right now you'll notice x is not alone. It has an exponent of 2. So to clear the exponent, you do the opposite, which is the square root. And by square rooting an exponent, what they do is they cancel each other out. And so that leaves x by itself. But if I square root one side, I have to square root the other side of the equation. The square root means you're looking for a number times itself that equals that number. So for example, 5 times 5 is 25. So the square root of 25 is 5. Your calculator has a square root button. So if you don't know what the square root is, I would suggest just clicking the button. Okay, let's talk about just a basic unit triangle and what would happen if the two legs were the same. So let's say we have a triangle. It is a right triangle. And let's say that this side is 1 inch and this side is 1 inch. We are wanting to know what is the diagonal. Now, one thing to notice is when your sides are the same, your two other angles have to be the exact same measure. There are 180 total degrees in a triangle, and we already know that this is 90 degrees. And if the other two are exactly the same, that would mean that they would have to be 45s. Because 45, 45, and 90 would make 180 degrees. Okay, moving forward, Pythagorean's theorem. A squared is 1 squared plus b squared is 1 squared equals, we're looking for x squared. 1 squared means 1 times 1, which is 1. Plus 1 squared, 1 times 1, which is 1, equals x squared. 1 plus 1 is 2, equals x squared. Last step is square root both sides. That leaves x alone. And in my calculator, I'm typing square root of 2, and I'm getting 1.414. So that tells me that my diagonal right here for where x is, maybe, this would be 1.414 inches, which is just under 1.5 inches. Now, this is kind of cool because this is called a unit triangle. It's as basic as it can get, 1 inch by 1 inch. And what would it happen if I just doubled? So instead of it being 1 inch by 1 inch, what if now I have another triangle? And let's say it is 2 inch by 2 inch. 90-degree angle. So all it did is its side lengths doubled in size. Well, if we're trying to find this diagonal, I placed it as x. I still could do 2 squared plus 2 squared equals x squared. Or we can make a nice observation. Whenever you have the same side lengths, which we do, 2 inch and 2 inch, this diagonal is always going to be whatever your side lengths are multiplied by 1.414. So if I take 2 and I multiply by 1.414, I would get 2.828 inches. And so that would be the length of the diagonal. What we just talked about will always work when you have two 45-degree fittings. So let's say we have a pipe, a pipe, a pipe, and let's say that right here you have a fitting, and it is a 45-degree fitting, 45-degree fitting. And what's going to happen is you can drop down a vertical measurement and a horizontal measurement, and you should see that you have created a nice right triangle. And whenever you have two 45s, which we just saw that we did, here's a 45 and here's a 45, that automatically tells you that whatever this measurement is going to be exactly the same thing. And then this measurement will be just that number multiplied by 1.414. So now let's look at Unit 18. And let's talk about, we'll do a problem really quick. Same scenario. Let's say you have pipe, 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 and this is a 45-degree fitting, 45-degree fitting. Let's call this a name here. We'll say that this pipe is what we're looking for. What's the measurement? And we're going to name that pipe K. And we're going to notice that from pipe K, you could go straight down and straight across and create a right triangle. And because we have 45-degree fittings, this is a 45-degree fitting, this is a 45-degree fitting, we automatically know that our side lengths are going to be identical, and the diagonal is going to be whatever the side length is multiplied by 1.414, because that is the constant for a 45-degree fitting. So let's say, I'm going to give a question here, that our offset equals 10 inches. And I want to know what is the run, and I want to know what is the diagonal. Oops. Okay, so my run is the horizontal, so this right here is my run. That means this is my offset. This is my diagonal. And they tell us the offset is 10 inches, so this is 10 inches. Now you should notice, your sides of your triangle are identical because you have 45-degree fittings. So my run is also 10 inches. And my diagonal is my side, so 10 inches multiplied by 1.414, which equals 14.14 inches. And that's just about like 14 and an eighth or so. I would have to do a conversion. What if we tried another one? Let's say instead of our run being 10 inches, what if it's given to us in feet? Let's say that our offset is 2 feet, 6 inches. So our offset is 2 feet, 6 inches, which means our run is also 2 feet, 6 inches. Now, I don't have a construction calculator on me. If I did, I would just type 2 feet, 6 inches times 1.414. and I would get a number, and that would be my diagonal. What I'm going to do, because I don't know how to type 2 feet 6 inches into my regular calculator, I am going to convert this number into strictly inches. So we know 2 feet is 24 inches, plus we have 6 more inches. 24 plus 6 is 30 inches. So this is the same thing as 30 inches times by 1.414. And if I multiply 30 by 1.414, I'm going to get some number. And that number would be the size of my diagonal, center to center. Okay, Unit 19 is just a build of what we just did. The only difference is once you've found your diagonal, multiplying by 1.414, you are going to find the end-to-end measurements for threaded, copper, and PVC. So let's say, for example, we're given that our offset equals 10 inches, and we want to know a couple of different things. We want to know what's the center to center, and what's the end-to-end for threaded, copper, and PVC. So what we're going to do, our offset is 10 inches. So up here, if I draw a picture of it, my offset is 10 inches, which means my run is 10 inches. And so to find this measurement right here, which is what we're trying to find, I would do 10 multiplied by 1.414, which is going to give me 14.14 inches. So my center to center was 14.14 inches. Now we're going to combine what we learned in the last units, 8, 10, 12, 15, 16, to calculate the end-to-end measurements. So let's say that this is a 3/4 inch pipe. And so I'm going to go to dado table 5 in the back of the book to see what my takeoffs are for a 3/4 inch pipe. So 14.14 takeoff. A 45-degree fitting 3/4 inch pipe has a 1 inch takeoff per fitting. So 1 inch on one, 1 inch on the other. Plus I have to add back my threads, which is a 1/2 inch. So that's going to leave me with 13.14 inches threaded end to end. And then I would solve for copper, and then I would solve for PVC. Now, one more thing that I forgot to tell you is if you have, say you've got your right triangle, and let's say instead of knowing what the sides are, let's say we don't know the sides, but we know that the diagonal is 6. If you have to work backwards, instead of multiplying by 1.414, you would just divide by 1.414. So to calculate the sides, I would go 6 divided by 1.414, and whatever I get would be the side length measurements of the triangle.